So today we're going to look at two incredible, almost unbelievable ideas that could completely reshape how we travel, both in the sky and up in space. We're talking about an engine that might not need any fuel and an airplane that might just be crash-proof.
All right, let's just dive right in with the huge question. What if an engine could actually break the laws of physics? Because that is the massive claim coming from a former NASA engineer. He says he's built a machine that can lift itself with zero fuel. No rockets, no exhaust, just electricity. I mean, if that's true, it changes absolutely everything.
And this brings us to the man himself, Charles Boer, and his company, Exodus Propulsion Technologies. He's chasing a goal that has honestly captivated space engineers for decades, this idea of a spacecraft that doesn't need any propellant.
Now, Boer has some serious credentials, okay? He worked on the Space Shuttle, on Hubble, on the International Space Station, and the team he's put together is packed with veterans from places like NASA, Blue Origin, and the U.S. Air Force. And together, they are claiming they've done the impossible, that they've violated one of the most fundamental rules of our world.
To really get how radical this is, you've got to remember basic high school physics, right? Newton's third law, for every action, there's an equal and opposite reaction. It's why rockets work. They violently shoot exhaust out the back. That's the action. And that's what shoves the rocket forward. That's the reaction. This new device, though, it supposedly moves forward without pushing on anything at all.
So, if it's not using that classic action-reaction thing, how in the world does this engine supposedly work? I mean, if you're getting motion without pushing against something, there must be some new, undiscovered force of nature that we've all just somehow missed.
And that's exactly what Boehringer calls it, the new force. The basic idea is that they use these really carefully controlled electric fields to create a kind of, well, an electric pressure imbalance across the device. So the object literally pushes on itself and moves. And get this, in 2023, they claimed they actually measured enough thrust to overcome the pull of Earth's gravity.
But you know what? They're not the only ones in this race. There's another startup called IVO Limited, and they claim they've built a similar fuel-free engine. It's called the Quantum Drive, and it's based on a theory that's, well, let's just say it's even more controversial.
Right. They think they're tapping into something called quantized inertia. It's a pretty fringe concept in physics, but it basically suggests that inertia, the thing that makes objects resist being moved, isn't a fundamental law at all. It's just an effect. And if that's true, you could, in theory, generate thrust without any propellant. And they believe in it so much that they've actually launched a test of it into space.
Now, this all sounds pretty revolutionary, doesn't it? But the scientific community is, to put it mildly, highly skeptical. And for a very good reason. Because, as they say, extraordinary claims require extraordinary evidence.
We've seen this kind of hype cycle play out before. Does anyone remember the EM Drive? It was another one of these devices that promised the impossible. It got a ton of media attention. Even a team at NASA reported detecting a tiny bit of thrust. But in the end, after more rigorous studies, it turned out to be nothing more than experimental error and measurement noise. The dream was over.
And here's the other huge red flag for scientists. If these new drives work the way they're described, they could actually violate the first law of thermodynamics. You could use them to create infinite energy, and that's the classic sign of a perpetual motion machine. And in the world of physics, that's a huge, huge hurdle to overcome.
So, while some big ideas are trying to rewrite the laws of physics, other innovations face a completely different kind of impossible challenge, the massive hurdles of engineering and economics. And that brings us to our next big idea, the crash-proof airplane.
Yeah, this one was actually born from a tragedy. After the crash of Air India Flight 171, 2 engineers from the BITS Dubai campus were just haunted by a question. Why are all of our safety systems designed to prevent crashes, but almost none are designed to help you survive one? Their answer is a project they call Rebirth, and it's this really complex, multi-layered system designed to do one thing: make a plane crash survivable. You can basically think of it as a giant airbag, but for the whole airplane.
And their approach isn't just one thing, it's like a symphony of 5 different technologies working together. First, an AI co-pilot detects that a crash is unavoidable and takes control. Then, seconds before impact, massive airbags deploy from the outside of the plane, literally wrapping it in a cushion. At the same time, reverse thrusters and gas thrusters fire to slow the plane's descent. Inside, the walls and seats are filled with smart fluids that instantly harden on impact to absorb the shock. And finally, the plane automatically deploys rescue aids to help first responders find it.
The ambition here is just incredible. I mean, in their simulations, the rebirth system showed it could reduce impact forces by as much as 60%. But this is where that amazing dream collides with the cold, hard numbers of modern aviation.
First, you just have to look at the statistics. As much as our fears might tell us otherwise, fatal air accidents are extraordinarily rare. You are, by far, safer flying than you are just driving your car to the airport. And that brings us to the really big trade-off. For an airbag system to be effective enough to cushion a giant commercial airliner, it would have to be absolutely massive. And if it's that big, it's going to be incredibly, unbelievably heavy.
So the real issue isn't whether it's physically possible, but whether it's practical. All that extra weight means a massive increase in fuel consumption, higher costs for everyone, and it would require a complete re-engineering of how we build airplanes, all to solve for an event that is already a 1 in a million kind of thing.
So, whether we're talking about an engine that defies physics or an airplane that can survive any crash, they both force us to ask a really fundamental question about progress, don't they? Where do we draw the line between a brilliant, world-changing dream and just a costly fantasy?